In this video lesson, I'm going to show you how we draw axonometric projections and oblique projections. The tools you are going to need are triangles, protractor, and a T-square again. So there are axonometric projections and oblique projections in parallel drawings. We are going to start with axonometric projections. There are three types of axonometric projections, being isometric, dimetric, and trimetric. So let's assume that we have a cube of 5 centimeters. First, I'm going to start with isometric projection. Isometric projections means that I will have a ground line for all of them. I drew it for all the projections. And then I'm drawing the height of my cube as 5 centimeters. Then I'm drawing that face of the cube with 30-degree angle as 5 centimeters. Again, for that face, I'm drawing 5 centimeters. Now I'm drawing the heights as 5 centimeters. Now I can connect the corners. Again, using my triangle. Now it's finished. So what I did to draw an isometric projection of an object, I use here 30 angle degrees. I didn't shorten any of the corners. I used 1:1 scale. My cube was 5 centimeters. Now all these edges are 5 centimeters. If I am asked to draw a dimetric projection, again I put my ground line first, then here I put the first corner of my object and its height 5 centimeters. In dimetric projections, these angles are a little bit different. One of them should be 42, so to measure that angle I'm using a protractor, a 42 angle, and this angle should be 7. Now, as I know my angles, I can draw that corners of my object. Here is 42 and here is 7. But now I cannot put the real measure of that corner because according to rule I should foreshorten it with 1 to 2, which means half of it 2.5 centimeters. But this side is again drawn as 1:1 scale, 5 centimeters. Now I'm going to put the heights of these sides as 5 centimeters. Now I need here a parallel to this, but I don't have a triangle which has 7-degree angle. So again, measure it with a protractor. I'm going to align it with my small triangle like that. And I should also align that one, or I can measure here 5. Yes, now I know that this is parallel to that one. Dimetric drawing is also completed. I used the angles of 42 and 7. I foreshortened that corner, but I didn't foreshorten that corner and that corner. So be careful that all these lines are parallel to each other, and these parallel to each other, and these ones are parallel to each other. It's same in dimetric also as isometric. All that corners are parallel and these are parallel. So that's why we call this drawing as parallel drawings. The last one of axonometric projections is trimetric. I'm starting with same operations. 5 centimeters, one of the corner. Here I have 45 degrees. And on that side I need 30 degrees. These angles are different in isometric, dimetric, and trimetric. I need to shorten that corner with 2 to 3, which means something like 3.3 centimeters. Now I can put here my corner 5. Also, I'm going to shorten that side with this ratio 6 to 7, which means that it's going to be something like 4.1 centimeters. I know that this angle is 30 degree. I can use that, or simply I can connect that points. I know that's 40 degree. Again, simply you can connect the points or draw with that. But if you draw with that, it's easier. Now my geometric projection is completed. For height, I didn't use any ratio. I drew it as 5 centimeters. But here, I foreshortened that corner with this ratio and foreshortened this corner with this ratio. Most used axonometric projection is isometric projection. So you don't need to know this, okay, angles. You can always check from somewhere. But isometric, the most basic one, is most used, and I suggest you to know these ratios. All of them are 1, and these angles. These were axonometric projections. And there are some oblique projections. And they are called elevation obliques or plan obliques. Let's start again with the ground line. Elevation oblique means that firstly I draw elevation of my object, the face of my object, the front face. I drew my elevation here. Then I can use 30 degrees, 45 degrees or 60 degrees to draw the other faces of my object. Let's use 60 degree for this. 5 centimeters. Okay, I'm always using parallel lines. I use a 60 degree. I didn't foreshorten any of the corners. They're always their exact dimensions in this elevation oblique. I could use 30 degrees or 45 degrees here also. And this elevation oblique is called cavalier. Another elevation oblique called cabinet. It's a special condition of that one. Again, the first thing, I'm drawing the front face of my object in exact dimensions of it. In cabinet drawings, I'm using a 45 degree. Now I shorten that size with 1 to 2 ratio, which means I'm drawing them 2.5 centimeters. As you can see, this cabinet drawing is a special condition of a cavalier drawing. They are both elevation obliques. So, in elevation obliques, to foreshorten this corner, you can use 1 to 1 ratio or 1 to 2 ratio, okay. But the front facade face of the object always in its exact dimensions. So these are elevation obliques. They are called elevation obliques because you first draw the elevation and then put the depth of the object in parallel lines. The last one is military drawing, and it's a plan oblique. Okay, these were elevation obliques and this is a plan oblique. So how I can draw a plan oblique? There are again some certain rules. Now you will need a 30 and 60 angle triangle. The first thing I should do is to put my corners of the object with 30 degree and 60 degree, okay, and draw the plan with these degrees. Here was 5 centimeters here, centimeters here. Here's my plan, and then I'm giving the height of the corners They were all of them 5. I'm not foreshortening any corner in this one. Okay, again, by using my triangle, I can draw these parallel lines with the specific angles. If I want, I can erase these back corners, or I can erase them like this to show them with dashed lines, which are we cannot see but exists in our cube. Okay, all the corners are in true dimensions, in exact dimensions. I'm not foreshortening them. These were parallel drawings, axonometric ones and oblique ones. These are the universal rules for drawing these paraline drawings, and you can use them in your architectural projects. They are quite useful. And that's all. See you in perspective drawings.